Hello everyone, I'm Alfian and today we are going to solve the Hackerrank challenge on the data structure section called the 2D array or two-dimensional array -ds, which is in the data structure section. And for the challenge, given a 6 by 6 2D array, and our class is a subset of values with indices falling in the following pattern, and the following is A, B, C, D, and E, F, and G. There are 16 hourglasses in a 6 by 6 array. The hourglass sum is the sum of the values in an hourglass. Calculate the hourglass sum for every hourglass in array, then print the maximum hourglass sum. And if we look over here, the first hourglass value, the sum, which is -9, and then -9 again, -9 again, it's all -9, except the one that is on the middle left and the middle right, which is the both are 0. And we shifted by one number, and we count the sum of -9 again, and then 1, and then 0, which is on the middle right here, and then -9 again, and 1, and we sum the current hourglass pointer, and there are 16 hourglass sums. Are the one is 63 and 34 and -9 and so on and so forth, and we get the highest hourglass sum of 28 from the hourglass beginning at row 1 and column 2. The row 1 and column 2, which is 28 right here. Row 1 right here and column 2 right here. And for this particular challenge, we are going to solve it using the Java 7. And if you want to use something else, I encourage you to do it. And for this particular challenge, I'm going to use the Java 7, so you will know better and learn better about learning about Java language. And if we look over here, the function says the integer as public static integer, which is the expected output from the name of the function, which is the hourglass sum, and it contains the parameter that name array with the data type of list of integer, and then inside the list is a nested list of integer or a nested array. So that's why it says an array, 2D array. And so let's declare the maximum value first, 0, and we, in order to get each of the 2D array, we can use the nested for loop for in I equals to 0 or equals to 1, and then as long as the I is below the array getting the array size, not get but size, since it's 2D array, then we need to define the length of the row first, or the surface first, the size, and then -1, and then we can count using the I++, but or the one the I should be 0, but since it's a 2D array and the in I0, let me show you something. So by using the I equals 0, and then we can use the system out print line and print our content of the array that I want to point out using the array get I, getting the content of the current iteration using .get, not the comma get, and then don't forget our placeholder returning max, and then let's run the code to see the system out print line, and we got the debug output of 1 1 1 0 0 0 of every row, as you can see, and it's form a nested array again, and the expected output is 19. And so in order to get the hourglass to make a pointer of resembles the hourglass, we need a shape with the reference point to make sure that we are not overlap the hourglass iteration. So let's say if we count it right here from the reference point of 1 right here, and then we are counting this one, this part of the hourglass, and then as we iterate our nested array, when it's going to be like this, and then for this one it's going to be like this, and then for this one it's going to be like this. And we should not determine the reference point right here, and we should limit our reference point to only right here, so it's only counting this part of the array iteration. And if we are going right here, then the array will be out of bound, and it will be returning out of bound error. And so it goes the same thing if we are counting vertically. So let's say if we are right here, and then we are counting this array, this part of the array, and then as we move up until this part, or this pointer right here moving, and this one should be the final one, because if we move into the right here to this reference point right here, it will be out of bound because it doesn't resemble an hourglass. So let's make sure that we limit our iteration to the last one, to the last reference point right here, which is 4, and then we are counting the last hourglass like this. So I drew something to visualize this using the Excalidraw. Let me select this part, and as we move the iteration by using the for loop, nested for loop of the I and j, let's say I and j, and then for the first iteration is going to be like this. It points to the 0 as the reference point, and then it's all valid, and they all can be summed into a new value. And for the next one, it's going to be like this, and like this, and like this, and like this. We are counting every each of the iteration, and then we are moving the right this and right this, and up to the point until we come to this part, and then this one, this one, this one, and finally this one. So we cannot, like I said earlier, we cannot count this part. We cannot move the reference point to this part because the bottom part right here, the bottom pointer, will be out of bound and it's not resembling an hourglass, and so hence it will be invalid. And it's also the same thing goes to this part. If we iterate up to this part, and if we are not limiting it, then it will be out of bound to this part, so we don't want that. And after this one, we should continue to this one. So for the red part right here, we are pointing right here up to the point to right here. Okay, to implement it, we need to have the pointer, and then using the pointer, since the horizontal will be counting the j, and then we need to add the j index using the +1. So in order to get the 3, we need to define the j iteration +1, and in order to get the 0, we need to use the j +2. And for this one, in order to get the number 2 right here, we need to use the reference point of the current iteration, which is 0 right here. Since 0 is just the I and j without the modifier or without adding or subtracting by 1, then we can use I plus 1, and then we will be pointed to the 1 right here, and then j plus 1 will be pointed to the number 2 right here. So this pointer is I plus 1 and j plus 1. In order to get the bottom part right here from 0, 3 and 0 again, then you guess it, using the I plus 2 and then j as it is, and this one is I plus 1 with j plus 1. Sorry, it's I plus 2 with j plus 1, and this one is I plus 2, j plus 2. So let me visualize this. If we are moving to the right part, it's going to be j. We are counting j plus. And if we are moving vertically, then we are using the I plus. So that's the rough explanation and the rough visualization from me. So let's go back to our implementation by using since the iteration right here, it's pointing to the full array, then we need to reduce it by using the still I equals 0 and then array size minus 2. And that way, if we use the system out the print line and we run the code, and the iteration should stop only right here on the row number 4. And if you look over here, the debug output stops at the 002440, which is at row number 4. And it's a good start. Then we can do the same to the for loop of the j value of the j pointer. J 0 as long as j is below the array of the I, using the get. Don't forget to use the get since we are using the list integer array list. Then we can use the get of the current I iteration and then chain it using the size and then minus 2 and then j plus plus. So let's use the system out print line again to see what I meant about it. And then we print the array get I and then getting again, chain with the get and get j. Don't forget the semicolon. And outside the for loop of the j, we can add the system out print line to debug, to find if we are going to the new line of the array reading right here. New line. For this one, we are using the print instead of print line. So let's run the code. And then as you can see, it's 1110. Oh, let me eliminate this one and run the code again. I'm eliminating the hyphen so you can see better. And this one is 1110, like this, 1110, and this one is 10100, this one, and all the way down to the 0024 right here, and it's enough, and it stops right there. And so we out to a good start here. And let's eliminate the system out print line. And let's implement our code by declaring an int variable called the sum. And then we calculate the hourglass shape of the array of numbers right here using this one is kind of complicated, so bear with me. Using the array of the array parameter and getting the index, we are getting the reference point first using the get I right here, the red square right here, get I, and then dot get j, and then plus, using the plus to get the one beside it, j plus 2, and then plus again, Let me enlarge this code so you can get the better idea. Let me enter this and then paste again, get j. Oh, this one is +1. Forgive me for the mistake. And for this one is j plus 2. J plus 2 is right here, pointing to the 0. And let's go back, and then we add a plus again and write on the bottom to get the middle part of the hourglass. See, don't forget the I plus 1 and j plus 1 and plus again. This part of the I plus 1 and j plus 1, it points to the number 2 right here from the reference point of the red square right here. So I plus 1 and j plus 1, it points right here. And using the plus sign again, let's copy this and paste this again. And don't forget it's +2. And then the j part is just j, and then plus, copy this and paste this, and plus again, paste this again. Finally, it's still I plus 2 and then j plus 1, just like the one above right here. And for the final one, which is j plus 2, and don't forget the semicolon. And we should check if the sum of the current hourglass, if the sum is higher than the current max value that we declare above and outside the for loop. If it is, then we can assign our max value to the new sum. And since the case has the possible value of minus or the negative numbers, since we are starting from 0, then we need to change the 0 using the integer dot mean value. Why are we using the integer dot mean value? Integer dot mean value resembles the system output line, resembles the value that is the lowest value of the possible integer of the integer data type in the Java language. So if we look over here, using the lowest possible value of an integer using the mean value, and then we run the code, and the lowest possible value of the integer value is -2 billion, I think. Yes, it's -2 billion, and that is the limit of the integer value using the integer dot mean value. Since we don't know the lowest possible value, then we can just declare the minimum underscore value instead of 0, because we are dealing with negative numbers. And so I hope it makes sense for you. So let's run the code again, and let's submit this code. Okay, so congratulations, that's about it. I hope you understand my explanation. If you still don't understand, then you can ask me in the comment section, or if you have any better solutions regarding the Java language, you can also write in the comment section and tell us what you think. Okay, so that's about it. I hope you have a great day, and I will see you in the next video. Goodbye.